So hi, these are my confessions as a microservices developer. Thanks for the introduction. I'm a software developer at Neo4j, which is a graph database. So apart from microservices, if you want to chat about graph databases and what they are, please find me at the drink section later. That's my Twitter handle. I know that I put myself out there to come and present here, but my self-esteem is really, really low. So if you were to say anything mean, keep it to yourself. I already know all the bad bits about me. So yeah, only nice things at that Twitter handle, okay? So yeah, let's start. So I started, this is my experiences as a software consultant for a gig that I was at a few years ago, where we were presented with a monolithic system, which was about 20 years old. It was written in C and some parts in Fortran and things like that. And the problem presented at hand was, doesn't matter what the development is, like it can be a bug fix or it can be a new feature request. After the development is complete, it would take them 3 months to reach production. So that's when they would start with the production process in itself. So they had like a 3 months window twice a year to get things into production. So they worked on a window kind of an environment. And it was a large publication company, and they were facing, like disruption in that space. And although they were the market leaders, it was very hard to keep monopoly going forward because the new companies that were coming in, they didn't have the weight of legacy tearing them down, and they were able to like quickly innovate, disrupt that space, which they weren't able to do because of all the constraints I said earlier. So we were thinking that the monolith is going to be like this, and we thought like, okay, well, let's start with microservices because it suited the problem that they were trying to solve. They didn't know what are the features that were in the product because, again, as I said, it was 20 years old. So we decided it's better to like invent things as we go by and see things which needs to be replaced or transformed into the new platform instead of like taking everything and trying to get everything in there. In a lot of ways, all the legacy that were there before was weighing them down in terms of not being able to, implement new things going forward. So yeah, so our idea was that it was going to be like a tiered, nice little cake, and we are going to replace it with like really small cupcakes or donuts in this case. So that was our complete intention. But reality was far from that. We were very, very naive in thinking it was going to turn out to be that way. Okay. So microservices, why we chose microservices for that problem was it presented us with an opportunity to fail fast and quickly and learn from our mistakes and learn and deliver software as we go by. So we have, if we were able to get into like automated deployments stage quickly enough, then we are able to deliver stuff quickly in front of the end users, and they can give us feedback on what works and what doesn't work for them, and then we just merely iterate on it over and over again. This is classic like agile software development thing, and microservices was the right choice for us because it just made all of that times 10 because we were able to innovate quickly and have multiple teams at the same time and do that. But it didn't come without its own dragons, and this talk is specifically around some of the dragons that we identified as we went by. I tried giving this talk a few years ago, and there were so many things to talk about in that one. I just decided to like have a smaller subset and talk about this. So I strongly suggest that if you're more interested, let's have a chat afterwards. So yeah, these are some of the dragons that we encountered. And hopefully I'll be able to tell you about how you can slay it or at least spot it in the first place. Anyways, so let's see whether how many of these problems identifies with you, whether you have microservices or not. Do you have a system that has multiple services that communicate with each other over a network interface? How many of you do? Good. Are your modules tightly coupled, which means that you have to deploy for a change in your software? You will have to coordinate the deployment or choreograph it in such a way such that you have a different set of services or modules being deployed at the same time, and it works only if all those deployments are working fine. How many of you have that? Okay, that's good for you. It's good to see that not very many people have that problem. I'm genuinely surprised, but unfortunately we did. Are you unable to do like an autonomous deployment, like where you're able to just go ahead with just deploy one service where you changed because you're afraid that it might break things, or you don't know what are the things that it might break because you don't have the safety net? Then it will lead you to having this problem of having no confidence in your system because you can't deploy one service and you don't know how it plays well with the other systems there. So the consequence, I'm just going to use this. The consequence of that is oftentimes people choose, even in a microservices architecture, they choose to deploy all the services fresh every time you go ahead and add a new feature. This happens far too many times. In that case, what you actually have, even though you're operating in a microservices environment, is basically a monolith. And specifically, it's a distributed monolith. As in, you have just because you have like 5 different services, doesn't mean that you're doing microservices, because all your 5 services need to be redeployed every time you have to go to production. That doesn't mean that you're doing microservices. It just means you're doing distributed monolith. Second set of questions. Do you have multiple, imagine this like in a, what do you call it? Like QVC kind of an ad. Like, is this you? Do you have multiple stakeholders who own different areas of the product, who all want like different features from the same product? How many of you have that problem? Okay, good amount of you. Are you unable to like narrow down on a business problem because you have confusing requirements from different stakeholders and they all touch the same part of the product and they want it done exactly their way? I've been consultant long enough to know that that is true for most of you. What has happened now in this case is like you are unable to you think that you have decoupled your services into different areas based on the product owners, but it hasn't actually worked because you're looking forward to interplay of those services and you're unable to identify features in a way such that like you're able to change only one area of the service and not having to change multiple other services. In which case, your consequence of that is actually, even though you're delusioned yourself into thinking you're having multiple loosely coupled services, whereas the minute you start tying down services and their deployments together, what it actually means is that you have tightly coupled services where you don't have clear boundaries or like clear contracts between those services. So you have been served by Conway's law, because what it means is, so let's have a primer on what Conway's law states first. So Conway's law says that organizations, the product that the organization produce largely resemble the communication between different people in that organizational structure. So surprise is when you have different product stakeholders asking for different things in the product, even though your system that you produce will have the exact same architecture as you would expect. And this also means that you think that you're decoupling your product into different areas, whereas in reality you're not. There's an excellent talk by Stefan Tilkov. I hope I'm saying his name right. And he says that you basically like disillusion yourself from into thinking that you're decoupling systems, whereas in reality all you do is like tie services together and then you try and deploy it and it wouldn't work and you end up deploying the entire thing over and over again. I highly recommend you to go and have a look at it, and it's really, really good talk. Okay, so he talks about techniques. So how do you solve this issue? You can choose to have your microservices designed in a way which follows the domain-driven design principles, wherein you identify how data and behavior is shared between two different services and their environment, and identify what contexts it is bound under, and then you implement your services, the APIs, and the behaviors between each of them accordingly. People often go for like an event-based system for communications between the servers instead of going for a synchronous request reply format. And there are a lot of case studies and books around that specific architecture, which I have added in my resources at the end. What he suggests is that people should, if you find yourself in a distributed monolith format, then what you should aim towards moving into is to have self-contained systems. What he defines as a self-contained systems is you basically have one service that has autonomous deployment. It has its own UI, it has its own database, so you don't have to maintain transactions between two different services, acquiring locks and all of that extra addition that comes into your sphere. Instead, what you do is concentrate on having your services defined by the features themselves, and the team will add features on top of those services. So they are largely singular unit of service. They might be big, small, micro, nano, it doesn't matter, but what you will have is an autonomous entity. Then you can start developing things on top of it and own the development from design to deployment, and that will help you harness every good things that microservices and serverless architectures could bring into the picture for you, without actually having to have the entire overhead of choreographed deployments. So specifically, let's talk a bit about bounded context. Martin Fowler, he has an excellent blog around what bounded context is. Basically what he says is like normal domain objects like customer, product, and territory, all of these things, it may mean different things in different contexts it operates on. For example, a customer in a sales context will have different functionalities. They might be more interested in the opportunity and pipeline of the product compared to a customer in a support context who is more worried about like your issues and things like that you have in the product per se. So the operations that's there on the customer entity in the sales context is not necessarily the same ones that you would expect from the customer entity in the support context. So your behaviors and your interactions for customers in those two domains are completely different. And it's important to identify the customer entity in its own domain and develop your services for the customer entity around that. I'm not arguing for an entity-based service, which is a whole different thing to avoid for various reasons. Anyways, so he suggests that you move towards a self-contained system, which is what we did towards the end of towards somewhere in the middle of the product. We had like 3 different services where if we had to add a validation on one of the downstream services, we had to add the validation all throughout on top. So we decided the best way to do it is possibly to have a validator in the first place and enclose all of these 3 services within our team, and for the people outside the system, all they worry about is using the client library we published. And if you use the client library in your system, and if the client library gives you an okay response, then you're good. From that point onwards, it's our headache to take care of. And at that level, we were able to have service contracts and things like that to help us move towards more to an SES kind of system instead of having like smaller microservices, which meant we had to deploy like small ones and like coordinate the deployment between the 3. So the next set of things. So this somewhere like 4 months into development, this really nailed on my experience in the moving between monolith and microservices. Like, congratulations, you have replaced a poorly built monolith with a poorly built microservices. Like, you have achieved nothing so far. In fact, what you have done is increased your problem multiple times. There was an excellent, yesterday I was in the serverless training with Mike Roberts, and one thing he succinctly put it was, with serverless and microservice, earlier when you have a monolith application, you have all your domain and all the behaviors between the objects and things like that contained in one big blob of code, which is your monolith. When you move that from monolith into like a microservices architecture, what you have done is you've identified what are the key areas in the product, yes, but you have also dispersed the knowledge of how these key areas interact with each other down to the infrastructure. And frankly, like many developers, we are not ready to hold that sort of information in our head. And with a complex, already your architecture is complicated, and you have the extra overload of having your infrastructure in your head as well. Every time you start writing code, like, oh, if I add this validation in this service, how does it affect like 3 other services down the stream? That's a lot of information to remember. Like, many times I don't understand why I walked into a room, or like I open a fridge, I don't remember why. Like, this is a lot of information for me to handle as a developer when I'm trying to add like one extra thing to the payload. It's too much of information to think about. So yeah, like, so what you have basically done is you have replaced your poorly built monolith into your poorly built microservices. And on top of that, because of all of this infrastructure constraint that comes in, if any time there's an outage happens, if you don't have proper logging, proper metrics, proper dashboards to identify that, good luck with that. Like, you have no idea where that thing has been suppressed, or like which circuit breaker went off, and you, like, good luck with finding that clue. And like, it's really like playing a game of Cluedo, or like murder mystery in this case. So what are the solutions for it? In my project, what we did was we stuck our guns to the testing framework. So we started with having lots of unit tests in every service that you go ahead with, which tests like important things like behaviors that the service are supposed to do. And then we do the integration test, which tests with its interactions with its dependent services, but these are like still stubs. It's not actually testing against real live services. And then we replaced it with functional tests, which were like more what happens when I call this, and this interaction 3 times in a row sort of thing. And then we had the user journey test, which is exactly what a user would play out when they open the website, go to this article, go down, click on one another article there, sort of thing. And that in itself wasn't just enough. It still didn't guarantee whether my systems were interacting good with each other. It still didn't guarantee whether if a newly deployed system would break my downstream dependency, because till this point we were just doing it against stub services. So we wanted to find out before things hit production, and then I'll have to go and find out why it isn't working. We wanted to find out before that. So we came up with a contract test wherein like every service would publish its own set of contracts that it will run it against every time after deployment to ensure that the contract tests are still working fine. So as long as your service and its contract was green, you were able to integrate it, because all you worried about connecting to was the contract. And this contract test, it's important to not write it to the level of the unit test, because your contract test should be quickly run. In our case, it was just a curl command checking the payload. So remember, when you write tests at that level, your response time should be like smaller. The time it takes for you to run all your unit tests should be longer than the time it takes to run your contract tests. And your contract tests, it's better to have them in a matter of seconds rather than minutes or like anything like that. Because what we then did was also include the contract tests as part of your health check, and there are limits on how quick your health check should respond in AWS specifically, because if your health check doesn't respond in the specified amount of time, it would just spin a new server, and that's not going to help in any way, shape, or form. Another thing that we did was to bring the infrastructure in-house, which is have your the ops, your sysadmins pair with the developers and try and like meet somewhere midway in between, because there were a lot of miscommunication around how a service would be deployed and not being able to understand the NAT servers and things like that. So there was a lot of difficult conversations very, very early, and like personality clashes in the product, but we finally reached at the end. So this is just a set of, so this is the first service that we did. I've used a mocked up image because I'm bound by confidentiality that I'm not supposed to actually show the details. But anyways, at the start of the first service, this is the amount of work we did infrastructure versus feature wise, and you can see in my mocked up graph, but trust me, like the actuals were very, very close to this. At the beginning it was mostly infrastructure work because we had to bring the old way of doing into AWS, and that took us a lot of work in infrastructure, and it meant that it took a lot of time for us to like actually understand how the path to production works. And as time went by, it just reduced. This is the second service that we added to the entire application, and that had considerably lower amount of infrastructure work upfront because we were able to build on top of the things that was available for the first service. And the third service, it was like literally half and half in a lot of ways. And I can only say that things improved from that time onwards rather than actually deteriorating. Of course, there were at times where we had the issue of one service would have solved a problem and another team would be working on solving that exact same problem, which is why we introduced service templates and things like that, where if you see it working in a few services, you're able to migrate it to other services without the additional cost of the infrastructure and things like that. I would strongly suggest I wish we had done this, or at least I wasn't aware that we had done this. I strongly suggest if you're in a monolithic environment and you want to move into the new age of deploying your application, you have a roadmap. Instead of starting like going in all guns blazing with like going and adopting a microservices architecture, it's often useful to improve what you have in the first place and like adopt things as you go by. So I would say, like, how many of you do automated testing in your application? Okay, that's a good amount of people who do that. But trust me, there are still organizations who don't do automated testing, who rely completely on a separate testing team once things have been like passed through like the development phase, and then you go and do the testing and then come back. It just merely makes your product delivery you slip your delivery so many times. It's important to like have these things in place before you could put your stuff out there in microservices or whichever architecture you choose. Just like first go for the automated testing. That's a very clear, easy win for you to go for before you could do anything else. And the second thing I would strongly urge you to do is have a path to production, even if it just means or you just go to the status page and it says all okay with the picture of Borat. That's fine, but you need to identify what that path to production are. Like the number of times I've been in a situation where we develop something and then we can't put it into production because it takes another 3 months of work to get it compliant, to get it ready for so many other things in the ecosystem that the clients are in. It's such a waste of time. Identify your path to production. The next thing, if you say that you have these two things, then try and identify how long does it take to go to production. Because people can say, yeah, it takes a year to go to production, but that still is a path to production. Try and reduce that amount to something reasonable as 2 weeks, because that's a decent amount of time where you can aim for if you have like a year's worth of work or something like that. Then I think equally important is also to have continuous integration. When you have a bunch of developers working on the code base, it's important to be able to like push it into whether you do branch-based strategy or master strategy, doesn't matter, but like make sure that you have continuous integration wherein your changes are continuously integrated with the main branch, and then you're able to like build on top of each other's work rather than pushing things one on top of the other and it may not work. In like it's like fixing, what's the phrase, round peg in a square hole sort of thing. Like don't do that. The next thing that I want you to concentrate on is whether you have continuous deployment. If you can reach until this stage, then you're doing really, really well. And then you can build on top of that, saying having your like deployments automated and having your alerts. These things should come before itself. But anyways, you have your alerts, metrics, and your dashboard set up for developers to see, and like ensure that you have the same kind of systems developed for your QA as well, so that your QA is very close to production and you identify your issues before it reaches production. Instead, wait for an outage. Like if anyone has been following the news recently about the DSP bank merger, like God, like I can't, like whenever I hear stories like the British Airways one a year 6 months ago and like the TSP merger, it's every time I look at news like this, it's 2018. Why would you do something like this? How is this not a solved problem? But this happens time and again, and it just frustrates me. Another thing, if you're starting off, is if you don't have your monolith service weighing you down, it's important to use in order to innovate quickly and deliver quickly. Like pick up any of these things that's going to solve your problem. If you're starting off newly, like if you're building a house, you don't try and build the, I don't know, like the waterworks along with it. Like you just plug into some system that is already available and use it. So if you have the means and if you have the way to go ahead and use one of these things, I definitely suggest that you should try and embrace it as early in your system as possible, because it's only going to help you in the long run. I don't see it going any other way outside. So this is my sort of summary of the entire talk. Look out for the dragons to hunt. If you're doing microservices, ask yourself what you're actually doing is distributed monolith. In that case, please go ahead and revisit your roadmap and understand where you're failing. And look out for entity-based services, because often when you have entity-based services, the way they interact with each other is not conducive to autonomous deployment. In fact, it derails you from that stage. And if you do have distributed monolith, then pay attention to your bounded context and understand where are you going wrong and identify your blockers there. Testing, if you're not doing it, if you're one of those people who say like, I'll test it in production, good luck. But like, please have some form of testing. I beg you, please do. Embrace new technology, bring infrastructure into your fold. Like my favorite one, I listen to a lot of podcasts, and one of my favorite podcasts is Business Wars by the Wandry Production. If any of you are interested in startups and how they work, please go have a listen. And they have like the first season was about how Netflix took over Blockbuster, and when if you were around that time and you see this happening, you're like, why didn't Blockbuster see this coming? And you have answers to that in that. And the next one is about, I think, IBM versus something else. I can't remember. But anyways, go please have a listen. If you're not going to embrace new technology, if you're not going to bring your development in-house in your product, you are going to be excluded soon from your competition. It is going to happen. It has happened to very big people, and you're not going to survive it. Take monitoring, logging, and metrics seriously. Like you own your system. With the infrastructure comes great responsibilities. Please own it seriously. And where is it? Yeah. If you don't have an adoption roadmap in place already, and if your developers, QAs, BAs, if they are not aware of it, fix that problem right away, because they need to know, everyone in your team needs to know what your adoption roadmap looks like and what your end game is. It's very easy for us to be bogged down by the details, but it's important for us to understand why we are doing it in the first place. Focus on improving the system in small incremental steps. I know, like, I wish I had instead of tackling like a big architecture thing right up front, I wish we had done this in small incremental steps. We would have avoided so many problems. But yeah, there you go. You live to tell the story. These are some of the articles that I built this talk on. I strongly suggest you have a look at it. And I really like following these many people. Like I have put my name there as well, because this year is going to be the year of me. I'm going to be out there. Okay, that's my Twitter handle. But yeah, there's Sarah and Mike here in the audience. Like, talk to them. Do definitely follow Kelsey. Whatever he says, do it. That's what I would say. I should actually have a point. Do what Kelsey says. Anyways, the images on this link. Thanks to Unsplash. I want to kind of finish this talk by saying, like, when you hear someone talking about microservices, remember that's one person's experience on talking about microservices. So when someone says, we just test it in production, you don't know what state things are in. You're probably listening to one person's view on what that is going to be, including me. When I say do test it, that's the same with me as well. Like, so don't take everything I say. I don't doubt you will, but don't take it like, use your best moral judgment. And that's my confessions of a microservices developer. Thank you.